Welcome to my channel. This is Moody. Please, if you haven't subscribed, please subscribe, do so, and also click the notification button so that each time I post a new video, you are alerted. So today's lesson, I'll be taking you through the introductory part of chemistry. When you're doing A levels, you need to understand this before you start doing your A levels, because if you don't do so, it will be hard for you to do what? To understand your A levels. So what you need to understand is that chemistry, you need to know the chemical foundation before you do anything in chemistry. So what do I mean? You need to have an understanding of the overall about chemistry, and also how nature and changes do what? Operate. Also the scientific methods and also scientific models, because these are very important for you to do what? To understand how chemistry operates, and also the unit measures and the uncertainty in measurement, also significant figures and the calculations involved. That includes dimension analysis and also any calculation under temperature, density, and also the classification of what? Matter. So now certain things in this video, I won't look at them because I've already covered them in other videos. This is why I'm encouraging you to subscribe so that you don't miss out. But those things which I won't talk about much in this video, I'll share. Just check my description. There I've added the links where you can find those videos so that you're not left out, so that you understand. But also in this video, I'll just touch a few points about them so that you're not left out. So now let's start. So scientific method and the scientific models. So you need to understand that in chemistry or in science, whatever science you're looking at, there's an approach which they use each time we're looking at something. So you need to understand. It starts with an observation. As you can see, look at this box. That's where it starts from. It just starts from what? An observation. Then from observation, then an hypothesis is produced. Then an hypothesis should have a prediction also. For instance, when you drink from a pool which is contaminated, are you expected to have diarrhea or to get sick? Not so. That's a prediction also. So what I said, that is an hypothesis, not so. You should drink from what? A dirty pool. What are you expected? So now, since we are looking at chemistry, let us base our understanding in chemistry. So like for instance, you say that when you add an acid here with a base, you produce what? A salt and water. So this on its own becomes what? An hypothesis. I did an observation. It started with an observation. You observed. Then you produced a what? An hypothesis. Then from hypothesis, you're able to have what? Predictions. Now these predictions, if they are true, if they are tested several times, that's when now a theory comes out, and also laws can be what? Can be produced. Minus this, so long as the hypothesis is not proven, it will continue the cycle. As you can see in this box, it will continue provided it is not what? Proved. So what do you need to know now when it comes to a theory? So a theory now, it's a further now proven with the help of what? Experiments. That's the reason why you'll be doing what? Experiments. The essence of doing experiments is to do what? So that you can prove the what? The theory. You see? Because from the experiments, that's where now you're able to now you have confidence in your what? In your theories. Then from that just from this box, also laws are what? Can be produced. So laws just summarizes what happens in this box, not so. Whilst a theory attempts to explain why things do what? Do happen. So that's what you need to understand. But before you even go any further, you need to understand that there's a law of what? Conservation of mass. What do I mean about that? So since chemistry will be just looking at the interaction of matter, how matter interacts with one another. So you find that certain things will change from one form to another form. Like for instance, here you have a cup of water, then you put it in a freezer, it becomes frozen, not so. So the water will be frozen. So as the mass of the water changed, that will be my question. No, it doesn't change. Even if it is what? It has become solid this side. So it has only changed one form to another form, but the mass still remains what? The same. So that's what you need to know. Energy only just changes from one form to another. It is neither lost also. So that's what you need to know about this. Then lastly, and on this part, You need to know that in science we use what we call models in explaining things. What do I mean about this? Let me just take you through. Just look at this. I'm sure when you are young, here in Africa it is common. You find that they will tell you that you bring some sticks, bring 10 sticks. Then from those 10 sticks, what they will be telling you is that get 3 sticks, then add with 2 sticks. How many sticks are you going to have? You're going to have 5 sticks, not so. So from this, if I were to ask you, do these sticks mean numbers? Not really. But these sticks will just help you to do what? To understand how numbers do what? Operate. So that when you grow up now, will be the same 3 plus what? Plus 2. Then to give you what? 5, not so. That's what these models also what? Do. What do I mean? You find that an atom, you don't know how you can't look at an atom, it is very small. Therefore, they will use a what? A model to do what? To explain what an atom is, so that from there you'll be able to do what? To understand. You just have an understanding about what? Atoms. Hopefully I've made sense about that. Then next we'll be looking at the units of measure. Units of measure, I won't explain much about this because I looked at this in other videos. So just check out. All you just need to know, you need to understand the basic units, then also the conversion, what it means. For easy understand, like for this one, 1 decimeter cubed is the same as 1 liter, because decimeter you need to know that it just stands for what? 10. Then when you cube root that, it will give you that. Then for you to just have a better understanding, here the prefixes, what they mean. Like there, deci means what? 0.1 or 10. That's all. Here. So now let us move to the other part, which is called uncertainty in measurement versus precision and accuracy. So like for instance, you encounter this in the lab each time when you're doing your labs. So this is a bullet. Now you're about to take the readings. So look at, as it's going down, the numbers are increasing. So look at here it is on 20, then here this is 21, 20.1. But what about here? What are we going to say? So you find that different people will have different readings, but you find that each person will have 20.1, 20.1, but the last numbers will be what? Different. This 20.1, this is what we call certainty, because we are certain that everyone has to find what? This number. But only the last number, it is what? Uncertain, because it will vary from one person to another. That is uncertainty and the uncertainty. So no wonder you just need to do what? To add this or these numbers to have what? Precision, to have accuracy, so that you better have an accurate answer. Then when it comes to accuracy and precision, what you need to understand is that for instance, look at these diagrams. So like this first diagram, your target is to hit this, but look at, you're hitting that side, that side, that side. The numbers here, what it means that they are not following each other. When you're taking readings, for instance, when you relate, they are not consecutive. They are not following each other. You find it 2, 5, 10, but that's it. But for this one, the numbers, they are consecutive, but they are not hitting the what? The target. So you find that there are somewhat systematic what? Errors. They are very large, even though the numbers are consecutive. But when you look at this, it is hitting the target, and also the numbers are what? Are within the same ranges, like the one which I had given you that example. So this is why you need to do what? When you're dealing with such, you need to add your numbers which you get, so that you find the what? The average. Hopefully this has been helpful to you.